Well, good afternoon, everybody, and welcome to our first session of the hydrogen unit for our Run on Less Messy Middle Bootcamp series. My name is Rachel. I'm the Industry Engagement Manager at NACFE, and I will be the moderator for today's session. If we could go to our next slide here, this is just a reminder that Act News is the group that provides all of the technical support to our bootcamp series. So if you haven't already, be sure to take a minute to subscribe for the latest clean tech news from the commercial transportation industry. Next slide, please. So as I had mentioned, this is the first session for our hydrogen unit. And in 2 weeks ago, we wrapped up our battery electric unit with a workshop. So thank you everyone who joined us and participated. We had an awesome turnout. We will have 2 more sessions during this final unit of our bootcamp series before our last workshop of the series. So make sure, as long as you are registered, you should have that on your calendar. Make sure to join us as we wrap up this series here. Next slide, please. So typically here is where I would turn it over to our Executive Director, Mike Roth, for a quick update from the run. However, he's not able to join us today, so I will be providing us with a quick update. As of today, we are officially kicking off the site visits to our fleets, which is the reason why Mike can't be here today. But at each of these visits, we are talking with the team members that are responsible for successfully deploying these alternative fuel solutions. We will have some great interviews, some great content coming out of this, so be sure to stay tuned while we release those fleet profiles. Next slide, please. And just to quickly get through our housekeeping items before I introduce our panel today, first and foremost, I would like to thank this session sponsor, Cummins. Thank you so much to Cummins for your ongoing support of not only this program, but as NACFE as a whole, to ensure that we can continue to provide programs like these to our audience. Next slide, please. And make sure that you head back to the landing page for this session on runonless.com to take your quiz. The speakers for this session have provided questions about the topics that we're going to be covering today. And just a reminder that once you successfully complete your quiz, you will be prompted to provide us with your contact information so you can be entered into a drawing to win some messy middle swag. You'll see that Google form to provide this information once you receive a 100% on your quiz. And as a reminder as well, you can submit your information multiple times to the Google form for every quiz that you successfully complete. This is going to be a maximum of 9 submissions. You'll have a greater chance at winning that drawing. And if we could go to our next slide here, our final reminders. This session is being recorded. It's going to be posted online later this week. If you did not have a chance to submit a question on your registration form and you would like to do so during the panel today, your Q&A controls are in the upper right-hand corner of your screen. During the Q&A at the end of the session, I will be relaying your questions to our speakers. And finally, Stefan Babcock with Act News is here with us today. He will help you troubleshoot any issues if you run into any problems during the webinar today. His email is here on the screen, so be sure to reach out if you're having any technical difficulties. Next slide, please. So we will go ahead and get started with that. I'd like to introduce you to our panel for our first hydrogen session today. Thank you so much to our panelists for being here. Our first presentation today will be from our organization's own Director of Emerging Technologies, Rick Mihalik. Rick, the floor is yours. Thanks so much.
Thank you, Rachel. Let's go ahead, Stefan, to the next slide, please. So when you talk about hydrogen, there's a lot of misinformation out there. Volvo came up with a great statement on one of their websites. Hydrogen is not an actual source of energy, but rather it's an energy carrier. If you think about it, hydrogen's really like a power line. It takes power from where it's produced to where it's needed. It's just another form of carrying energy. Next slide, please. So there's a number of ways of making hydrogen. This again is from Volvo's website, but it's essentially often talked about as a rainbow, a color spectrum, with white hydrogen being naturally occurring hydrogen, green hydrogen being that produced from electrolysis with electricity, pink hydrogen is just another way of getting electricity from nuclear power plants. Yellow hydrogen is another way of doing it with nuclear energy. Blue hydrogen, turquoise hydrogen, gray, black, all these colors tend to confuse people. But essentially, you're using a lot of energy to create hydrogen, and then you're using hydrogen to transport that energy somewhere, and then it's turned back into something useful, electricity, where it can be deployed and used to move a vehicle down the road. So there's some key questions here that you need to always keep in mind when people are talking about this is how is it produced? Where is it produced? How is it transported? What is the carbon intensity? And I'll get into that a little bit later. And then why are you using hydrogen? Next slide, please. So another way of looking at this is kind of a map showing you that there's a number of ways of making hydrogen. And part of that is how do you transport it? You can transport it by pipelines. You can transport it by trucks. It can be moved as a gas. It can be moved as a liquid. At some point in time, it has to be converted back into something that's electricity in order to move a motor, in order to get something to actually move. There are other uses for hydrogen. Hydrogen can be turned into ammonia. It can be it's used in the process of creating petroleum. Right. So today there are some 10 million megatons of hydrogen produced and used in the United States. And, if there's really no hydrogen transportation in the US today. And so there is a lot of use of this. It's been in use for decades. It's not a new industry. Applying it to moving trucks is a new industry, but it's something that's been talked about for decades. Next slide, please. So one of the key things to think about is what is the carbon intensity of producing the hydrogen and using the hydrogen? And that discussion gets very complicated very quickly because when you think about putting gasoline into your car or putting diesel into your truck, you usually measure things from that pump and it going into the vehicle. And so it's usually the pump to wheels analysis that is easy to conceive of because that's what you're paying for. And you don't really think about how did that energy get to the pump in the first place. With hydrogen, it gets a lot more complicated because you really need to think about how did that hydrogen get produced. The 9+ different ways of producing hydrogen all have their own carbon intensity in getting that energy to the vehicle. And so you really need to think about what is that starting point you're thinking about and what is the end point that you're measuring. And there's lots of interpretations of that. And so you have to be really careful when it's being discussed in the media. What are they using as a starting point and what are they using as an end point? And are they doing apples to apples comparisons in that in terms of the carbon intensity? Next slide, please. Something that often gets confused and misinformed is that somehow hydrogen magically disposes of the need for electricity. The reality is that hydrogen doesn't exist without electricity. You saw in my initial slides that there's several ways of producing hydrogen that require electricity, but once that hydrogen is produced, there's also a good deal of electricity needed in storing it, transporting it, compressing it, and dispensing it. It's something that often gets overlooked is that you do not magically get out of jail free by using hydrogen. The hydrogen and electricity coexist and they require each other in order to be useful. Next slide, please. Now, a little bit about the vehicles. these are two examples of vehicles that are using gaseous hydrogen in tanks stored behind the cab or behind the sleeper. One of them uses a system that's very similar to today's combustion engine in order to burn the hydrogen in order to create motion in the vehicle. The other one uses a, electrolysis to essentially create electricity back from the hydrogen and then puts it into both batteries and into the electric motors to move it. There is another image missing here in that they're starting to talk about using liquid hydrogen in some of these vehicles. And again, it's just a different way of storing it on the vehicle. It has some different complexity to it because the hydrogen has to exist at very cold temperatures and but it looks a little similar to a current diesel truck in that the tanks are usually saddle mounted on the rails of the vehicle. Next slide, please. Now, you're needing to produce this hydrogen. There is a lot of cost associated with moving the hydrogen from where it gets produced to where it gets used. And so a lot of the discussion really looks at putting large manufacturing of the large production of the hydrogen near where it's used so that the pipelines or the tanks or the virtual pipeline, which is just another phrase for trucking it somewhere, um, that gets very short. And so these are three examples of production facilities. You notice that they get larger and larger the more trucks you have to support per day. And so the largest image here on the right is a production facility hypothesized for a basically a truck stop that would be servicing 100 semi trucks per day. And that usually means 50 to 80 kilograms per vehicle, depending on how the trucks are used. Next slide, please. Now, as I said, hydrogen is produced today in a number of places. It's usually trucked to where it's needed. It's used in producing petroleum. It's used in producing ammonia for fertilizer. Um, the figure in the lower left-hand corner shows where the hydrogen is currently produced in the United States, and the diameter of the circle basically indicates the amount that's produced in those locations. Um, there's been a lot of discussion over the last several years about hydrogen hubs. These are locations that are being developed to really service producing the hydrogen and using it in industry. And they're kind of located in different regions of the United States because there are different primary modes of producing energy in those different locations. So, for instance, the Gulf Coast has a lot of petroleum infrastructure, and so they already have 800 miles of pipeline there for moving hydrogen around, and because they use it in the petroleum manufacturing. If you look in the Northwest, um, that area is making a lot of electricity through hydropower, and so they have a different formula really for optimizing production of hydrogen. Uh, Canada similarly is got some diversity in how they produce energy, and so the mix of how you produce it is different depending on which province you're in. Next slide, please. Now, hydrogen hubs were part of a funding effort that came out of the last administration. Now, where that's going in the future is anybody's guess. Some of these are being affected by the newest administration's plans. Some of them are in lawsuits. Some of them are going ahead anyway, irrespective of what happens at the federal level. Some of these are relying on state funding. Some are relying on commercial funding from groups because they see a business case for this. Um, so we'll have to see where this goes in the future, but these hubs are really foundational efforts to increase the capacity of hydrogen and make it possible to use these for transportation and other purposes. Next slide, please. And I'm going to close up here. This is my contact information. Rachel will talk to the sources that we are providing. We wrote 2 in-depth reports on hydrogen that are available from our website. And there's a number of really good sources for hydrogen from the EIA, the Energy Information Administration, and from the DOE. Thank you, Rachel.
Thank you. Thank you so much, Rick. And as Rick had mentioned as well, so we are providing resources to this, so they'll be linked out on the landing page on oneonless.com. Rick has provided some resources. Our other speakers have provided somebody. Thank you to the person who dropped the DOE resource to greet in the chat. I will be linking that out through our website as well. So keep your eyes open for that. But we'll go ahead and move to our second presenter today. Next up, we have Omar Chowdhury, who is the Sales and Business Development Manager for the U.S. with Accelera by Cummins. Omar, thank you so much for being with us today. I will.
Hey, thank you, Rachel. Really appreciate it. So, good morning, good afternoon, everyone. I'm Omar. I'm the Sales and Business Development Manager for the US for Accelera by Cummins. And by the end of my brief presentation, I'm hoping you'll learn a little bit about how electrolyzers work, current applications where hydrogen is used, and the commercial and policy state of the industry. So, if you go to the next slide. So Cummins is mainly known for being an engine manufacturer as well as supplying diesel generators. So over our 109-year history, it's grown to 35 billion in annual revenue with nearly 70,000 employees. Now this growth is part due to various strategic acquisitions that Cummins has made over the years, specifically within the renewable energy space where Accelera is housed. So if you go to the next slide. So Accelera by Cummins is where all of Cummins' zero emission technology are housed. This includes e-mobility, fuel cells, as well as the electrolyzers. I'm part of the electrolyzer group, and what I'll be speaking about is that specifically. So if you go to the next slide. Great. So a water electrolyzer is a clean energy device that uses electricity to split water into hydrogen and oxygen, enabling the production of green hydrogen with zero emissions. This process is known as electrolysis and requires a theoretical minimum voltage of 1.23 volts, but practical systems operate between 1.8 and 2.2 volts due to energy losses like resistance and overpotentials. When direct current is applied, water molecules are broken down at 2 electrodes, hydrogen forms at the cathode, and oxygen at the anode. The hydrogen produced can be used for clean fuel as well as vehicles and energy storage. So if you go to the next slide. Great. So hydrogen is far more than just a fuel. It's a fundamental building block of modern industry, valued for its unique chemical properties. Today, around a large portion of current hydrogen used is used for ammonia production, which is essential for fertilizers that feed billions of people across the world. About a quarter of the hydrogen produced currently goes into oil refining, where hydrogen helps upgrade crude oil into lighter, cleaner fuels like gasoline and diesel. Another 10% is used in methanol production, a key ingredient in plastic, resins, and solvents. The remaining 10% is split across various industrial applications, Hydrogen is used to, for instance, reduce metals, prevent oxidation, and cool generator thanks to its chemical reactivity and thermal properties. While only a small percentage of hydrogen, less than 1% today, is currently used as a fuel, that share is rapidly growing as hydrogen becomes a clean energy carrier in sectors like transport, power, and storage. In short, hydrogen underpins today's industrial world and holds a key to tomorrow's clean energy future. If you go to the next slide, I'll speak a little bit about the applications that are currently using hydrogen. Thank you. So the first one is power to power. So renewable electricity is converted into hydrogen via electrolysis, stored and later converted back into electricity when needed. This concept has gotten a lot of critique from the industry just because of the energy losses of taking electricity, converting it to hydrogen, and then converting it back to electricity. Where this application actually makes sense is if you look at grids that are designed for peak load and have excess power during base load, they can use that excess power to produce hydrogen, which they can store and use at a later time. Next would be power to gas. So hydrogen can be injected into existing natural gas pipelines, for instance, blending, or converted into synthetic methane. This allows renewable electricity to decarbonize the gas sector using existing gas infrastructure for heating, industry, or power generation. Next would be power to industry. So many high temperature and chemical industrial processes rely on fossil fuels. Hydrogen offers a clean alternative. For instance, for steel making in direct reduction, as well as cement, glass, chemical production as a reactive feedstock or a heat source. Next, we have power to fuel, or what we call today as e-fuels. Hydrogen can be combined with CO2 to make synthetic fuels like methanol, ammonia, or e-diesel, which are compatible with existing engines, ships, and aircrafts. This enables carbon neutral fuels for hard to electrify sectors such as aviation and shipping. So there has been a significant push from airlines recently, both United Airlines as well as Delta have signed MOUs to essentially convert a big portion of their fleet to use SAF fuel. So we're noticing an uptick in these applications currently. Lastly, it would be power to mobility. So hydrogen is used as a for fuel cell vehicles, so FCEVs, car, trucks, buses, trains, and even planes, where it reacts with oxygen to generate electricity and emits only water as a byproduct. So in conclusion, hydrogen enables renewable electricity to go beyond the grid, transforming it into gas, fuel, industrial heat, and mobility applications. From power to industry, fueling zero emission transport, hydrogen is a versatile connector that makes truly sustainable energy systems possible. So if you go to the next slide. So here I'll talk a little bit about our current product offering. We have both a containerized system as well as an industrial system that would require the balance of plant to be developed by, for instance, an EPC. The product that you see on the left is a turnkey solution and is really great for applications such as hydrogen refueling stations. So, up to a ton a day can be produced using these containerized systems and really can be applied all across the US to really increase the amount of hydrogen refueling stations across the US. Now on the right, mainly the applications that we see for the indoor units is industrial applications. And these include many of the ones that I just spoke about. And this requires a plant to be built, a balance of plant to be provided via an EPC for this solution. So if you go to the next slide. If you go to the next slide, thanks. Here is just a few of the applications that we have all across that we've supplied electrolyzers to. So for instance, there's one in Bécancour, Quebec. That's a 20 megawatt facility using our Hylyzer 1000 And the application for that is they liquefy that hydrogen and provide it to various industrial partners in that region. Another one I would like to point out is a project that we're currently working on, and it's with BP Lingen in Germany, and that's a 100-megawatt facility. Once that is installed and commissioned, that would be one of the largest PEM sites globally for hydrogen production. So as you can see, there is still quite a demand for hydrogen electrolyzers across the globe. Currently in the US, the policy hasn't really supported the industry to grow, and I'll touch a little bit on that in the next slide. So if you go to the next slide, Stephen. Great. So currently the state of which, the policy state of which hydrogen is sitting in is due to the IRA, specifically 45V, and oil and gas companies are lobbying to maintain the production tax credit. However, it was recently just voted down from the House and it's going to the Senate, and it's due to be cut. Now, this isn't final. We're still waiting until the Senate votes on this. A hopeful case for 45V is that a large portion of the funds that will be gained will flow to Republican districts. Nearly 75 to 85% of the funding that is generated from these projects would be for Republican districts. So due to that, we're hopeful that the Senate doesn't eliminate 45V completely, but that remains to be seen. So the last message I'd like to leave you with is when the dust settles, blue hydrogen will likely become more attractive to investors as opposed to green hydrogen from a policy standpoint. So I think that's all the slides that I have. I'll include my contact information if any of you would like to reach out or have any questions.
Perfect. Well, thank you. Thank you so much, Omar. Finally, we have our last presenter, Connor Dolan, who is the Vice President of External Affairs for the Fuel Cell and Hydrogen Energy Association. Connor, thanks so much for being the anchor to our presentation today. I will pass it over to you.
All right. Thank you so much, Rachel. Really appreciate the opportunity to speak to you all today. I'm going to expand a bit more on the blue hydrogen side of things and some of the policy debate that's underway actively right now. But I am Connor Dolan, the Vice President of External Affairs for the Fuel Cell and Hydrogen Energy Association, FCHEA. Go to the next slide, please. So FCHEA is the national association representing the hydrogen sector here in the United States. We're based in Washington, D.C. and been around for over 35 years. We represent over 100 companies doing hydrogen production, distribution, and use. So our members include a variety of the folks across the production landscape doing blue, green, gray, pink, turquoise, every other color under the sun that you've heard of today, as well as the folks in the midstream space moving and storing hydrogen in large scale and in large quantities, including some of these massive salt caverns that are being expanded on. And on the end use side, we include some of the traditional automakers, the truck manufacturers, as well as folks across the other remaining set of the landscape here. We represent the industry here in Washington to regulators, policymakers, and the media and the communication sphere, and focus on the benefits of hydrogen. So if you go to the next slide, please. And this will just be a snapshot of our member companies to give you an idea of who we are representing. Again, some of the large brand names and biggest names in the the energy space around the world, as well as some folks that are in the smaller supplier communities and others across the industry. Go to the next slide, please. So I want to just first take this at a very high level. Why are we even talking about hydrogen? There's a lot of benefits to the hydrogen economy and why we're investing in this space. Hydrogen offers a lot of resilience, reliability when it comes to power. You can create hydrogen from a lot of different sources that we just heard from my predecessor, Omar, the green hydrogen side, being able to take solar and wind power that are being produced in excess quantities, storing it for large scale, long term, and then using it to create energy back on the grid is very beneficial. There's also a huge opportunity for economic growth and employment, jobs and manufacturing. We have a huge amount of investment underway, ready to be unlocked here in the United States in the hydrogen economy, building gigawatt scale factories, growing and expanding these large scale hydrogen production, distribution, and storage facilities. All of this is going to help drive economic growth and opportunity. There's also a huge advance in reducing emissions. The climate is a very big issue. Hydrogen solutions have zero carbon included in them, so there is a huge benefit to the economy by using hydrogen technologies. And global competitiveness. This is a global hydrogen race underway right now. There is interest from just about every major economy around the world. China, Japan, Korea, the European Union, the Middle East, they're all investing billions of dollars in this space. There is an understanding that the hydrogen economy will come to be in some form or another, and it's just a matter of where it's going to be. So we want to make sure that we maintain our American technology edge and have this development here in the United States. So go to the next slide, please. All right, so on the uses of hydrogen, I know we've talked a little bit about this. If you just tap forward a couple times, I think there's 4 different pieces that'll pop up. We can just talk about some of the different use cases here. Power generation and grid balancing, as I mentioned, you're using hydrogen for centralized backup power or hydrogen as an energy source. Hydrogen is a feedstock for ammonia, methanol, steel, refineries, long distance transport of fuels like SAF and marine fuels. That all of these fuels and commodities, hydrogen is the base building block of just about all of them. They need to have hydrogen, and often they are desired around the world for their clean hydrogen, low carbon intensity. So having clean hydrogen commodities built here in the United States to go towards low carbon ammonia, low carbon methanol that's desired in the EU or Korea or Japan is really desirable. So that's why we want to build these facilities here, as well as benefiting obviously the American economy. Having homegrown ammonia and fertilizer here in the United States is obviously a big benefit to the farming community, agriculture community here in the US. Fuel for residential commercial buildings, you can blend hydrogen to the natural gas grid. You can also use hydrogen directly as a heating stock for some cases. And then transportation fuel is obviously a very, very big one. There's 70,000 fuel cells operating today for material handling equipment. There's something like 16,000 light duty fuel cell vehicles on the market and on the road in California being driven by consumers today. And there's a huge demand and opportunity for heavy duty market for transportation, as well as getting into rail, aviation, and marine propulsion. But don't want to belabor too much on the use cases because we're here to talk about hydrogen production. So if you go to the next slide, please. So I want to talk about where this industry is growing. We have a huge opportunity to expand hydrogen production here in the United States. This is based off a study that we did back in 2020, but it was reinforced with very similar figures from the National Clean Hydrogen Roadmap and Strategy produced by the Department of Energy, which is going to be included in your resources today. There is an opportunity to build about 50 million metric tons of hydrogen here in the United States over the next few decades by 2050. This is going to be serving transportation fuel, fuel for residential commercial buildings, this industrial application, synthetic jet fuel, ammonia. All of these are very anticipated to take off very dramatically with the right policies in place. At the end of 2050, hydrogen could account for 14% of U.S. energy demand. And this is going to be, all these opportunities are going to be in clean hydrogen production for what we're going to be building here in the United States. So you go to the next slide, please. So while today most of the hydrogen production is gray hydrogen, that's at the top of this chart here, or fossil-based hydrogen using natural gas with steam methane reforming, that is what's commonly being used today. We're really going to talk about the suite of clean hydrogen options that are out there. Clean hydrogen is low and zero carbon hydrogen produced from a variety of methods here in the United States. Our association supports a pathway agnostic approach to advancing clean hydrogen. No matter what opportunities there are, all of them are going to be reducing emissions in some capacity compared to our existing hydrogen production from gray hydrogen, and we are very supportive of all of the above approach there. So we have naturally occurring hydrogen is in development, which is going to be drilling hydrogen from under the ground, these kind of naturally forming hydrogen deposits that's been found very recently. We have some members doing that. We have pink hydrogen, which is nuclear, turquoise, which is methane pyrolysis. It's very similar to gray hydrogen, but instead of having CO2 as a byproduct, you actually turn it into a solid carbon black product. So we have some companies like Monolith Hydrogen that are developing that. That carbon black can be used for a variety of industrial needs, including tire manufacturing, which is something we usually import carbon black products, producing here in the United States is great. And green hydrogen, which is from electrolysis of renewable electricity. But I want to elaborate a bit more on the blue hydrogen side of things, which is fossil hydrogen with carbon capture and sequestration. So go to the next slide. This blue hydrogen is the ability to take our existing capacity of resources, add carbon capture and sequestration, you'll dramatically reduce the emissions and continue to use those resources. So you can store that hydrogen, use that, it generates hydrogen, and then it also generates CO2 that can be stored and captured underground or utilized for a variety of resources. So if you go to the next slide, please. So why blue hydrogen? There's a lot of different options here, or reasoning here. We've often heard, why aren't we just investing in green hydrogen? We are absolutely supportive of green hydrogen and the electrolyzer community. Accelera is one of our members, and we are very supportive of that. But we do think that an all of the above approach is necessary, and that blue hydrogen has a unique role to play here. First, it's going to be driving energy independence and economic growth. We're using our domestic oil and domestic natural gas resource, creates greater energy security while creating jobs in manufacturing, construction, and operations. There is a study that came out from Citizens for Responsible Energy Solutions that says that there's 60,000 jobs on the table immediately in the blue hydrogen space once we get this policy certainty underway that we'll talk about a little later. So this is a huge opportunity for economic growth and jobs. Emissions reduction is another big one. No matter what the form of clean hydrogen, blue, green, pink, turquoise, they're all going to have reduced emissions compared to our existing gray production. So you can even compound that further if you're using natural gas with low carbon intensity, responsibly sourced natural gas or renewable natural gas, where you can continue to use that along with carbon capture and sequestration to really drive emissions down extremely low. Another one is you're going to be cleaning up our existing facilities. Retrofitting those facilities immediately reduces our carbon intensity of the hydrogen industry. This is a big benefit, and these facilities are often already co-located with heavy industries like refineries and petrochemical plants. There is an appeal for global markets. As I mentioned earlier, European Union, Korea, Japan, they want clean hydrogen derivatives like ammonia and methanol, and being able to make blue hydrogen to go into that is very highly desired. And then lower cost. Right now, green hydrogen is expensive. As you can see on the chart on the right, it costs somewhere today between $5 and $7 a kilogram. There's opportunities to lower that over time by getting cheaper electricity costs, by lowering capital costs for equipment, scaling up that, improvements in efficiency, durability, utilization. It's going to take a few more years, but in the meantime, while the green hydrogen industry and electrolyzer community reduces costs and grows scale, we can immediately advance the blue hydrogen space, which only costs about $1 per kilogram today. For comparison, gray hydrogen is roughly, just natural gas based hydrogen without CCS, carbon capture and sequestration, costs about $1 per kilogram. So for a minimal investment of 60 cents a kilogram, you can get much cleaner resources and drive that ahead today. And ultimately, this is going to be a bridging solution while we are scaling up and reducing costs for the green hydrogen space. Blue hydrogen development and adoption can immediately scale our necessary infrastructure for storage and distribution, and the end use side on refueling stations and the like that are going to be critically needed in the future. So overall, blue hydrogen has lower cost and lower cost compared to green hydrogen. It does have higher emissions. If you go to the next slide, you can see a bit more on that front, but it's lower cost than green hydrogen, and it has lower emissions than gray hydrogen, but it's certainly not as clean as the green hydrogen electrolyzer space. So that is an important distinction there. Where there is a bit more emissions compared to green hydrogen generally, it is have lower cost. So if you go to the next slide, please. So just a couple examples of some blue hydrogen facilities that, these are very massive, large scale facilities that are in development. I have an example of Air Products Louisiana facility. It's a $4.5 billion investment. They're going to be building some natural gas-based facilities for CO2 capture using in Louisiana that are going to be using some underground facilities. Then they're going to be shifting that hydrogen around for a variety of use cases, including blue ammonia that'll be exported to global markets, or sharing that blue hydrogen down the distribution pipelines that they already have around the Gulf to a number of their customers that already exist. This is going to create hundreds of jobs, 2,000 construction jobs, and it's going to be extremely beneficial to the local economy down in Louisiana. Another example is the ExxonMobil Baytown facility. This is a $10 billion investment. This is the world's largest hydrogen production facility that's in development. It's going to produce 1 billion cubic feet per day of low carbon hydrogen. It's going to be used for both the existing refinery operations down in Baytown, Texas, and that surrounding area outside Houston, as well as generating blue ammonia for export opportunities. So the big piece here is that blue hydrogen has a much greater scale and big opportunities in that space. If you go to the next slide, please. I know we're getting shortly down on time, so just want to talk about the Section 45V credit for the production of clean hydrogen. This is a credit that's based on carbon intensity. It was created by the Inflation Reduction Act of 2022 under the Biden administration. It would be a 10-year tax credit for facilities that begin construction before January 1, 2033. They'll be able to get a 10-year incentive for every kilogram of hydrogen they produce. They can get up to $3 back from the federal government. And you can see this little chart on the right. It's a scaled incentive. So the cleaner the hydrogen, the greater the value of the incentive. Green hydrogen is really going to be that one hitting that $3 per kilogram range. And again, that's because the cost for green hydrogen is somewhere between $4 and $7. So $3 has really helped to bring costs down closer to the cost of gray hydrogen, which is about $1 per kilogram. On the flip side, you have blue hydrogen that's probably going to be in these lower tranches, 60 cents to $1 per kilogram. And that's because it'll help cover the cost of CCS and equipment purchasing, lower incentive or lower carbon intensive natural gas or renewable natural gas, and be able to get recognition in that carbon intensity for those credits. So it's interesting reasoning between that bifurcation there. If you go to the next slide, please. So the status of 45V today, the Trump administration has been pretty tricky. First of all, we didn't really have any favors done to us by the Biden administration and Biden regime. While this tax credit was created in August of 2022, we did not get the final rulemaking for it for how to actually take the tax credit until January 3rd of this year. And the reasoning for that is that the Biden administration really belabored over what sort of regulations and rules should be required to meet those different carbon intensity standards. They wanted to have some very strict measures in place to limit this ability of this credit to scale and cover a number of sectors. And ultimately, it came out in a workable solution for industry. It's not ideal, but it's something that we could largely live with. But because it did not it was not issued until January 3rd of this year, our industry was held in a holding pattern for the last 3 years, unable to actually move to FID for any of these projects. And we're still in that holding pattern today because we immediately went into January 20th with the new Congress and this immediate conversation around reconciliation and elimination of the variety of these IRA tax credits, including 45V. So our association has been doing a lot of work, working with a variety of the other energy and business trades here in DC to push back on this and try and keep 45V on the table. We've had a lot of meetings, we've done letters with various groups, a lot of communication activities. Unfortunately, the House markup is a little old. It's not last week, but it was a couple weeks ago, proposed to terminate 45V at the end of this year with a new begin construction date that would be set at December 31, 2025. There's a number of other tax credits that are going to be phased down starting in 2028 or 2031, but really this is going to be pushing 45V much earlier to conclude again only at the end of this year, which means that virtually no projects will be able to receive it. Our focus right now is on the U.S. Senate. We're taking a number of steps to try and defend this tax credit and get some restoration back on the table here, hopefully getting to a new begin construction date of ideally 12/31 of 2029. That is a date that is largely agreed on within the energy and business community here that care about the hydrogen credit, that is something that is achievable, winnable, and something that will work for us. So that is the state of play. It is tricky. We do very much need this tax credit to remain in place to support all these projects, blue, green, pink, turquoise, and everything else under the sun. Without 45V, there is going to be a dramatic reduction in these hydrogen production facilities. And it doesn't mean that these hydrogen production facilities are going to go away altogether. It just means that those investments are going to go elsewhere. They're going to go to the European Union, they're going to go to Asia, the Middle East, and these countries and regions that have more beneficial policies or ability to scale there. 45V was the key differentiator between building clean hydrogen facilities in the United States versus elsewhere for a lot of these large major corporations and companies. So go to the next slide, please. The other big piece of debate underway right now is the regional clean hydrogen hubs. Again, this is created by the Biden administration under the bipartisan infrastructure law of November 2021. It would create a number of hydrogen hubs of large-scale hydrogen production, distribution, and use activities. The Biden administration, again, here really took its time on getting these hydrogen hubs announced and awarded. The final contracts for the last two hubs were not signed until January 17th of this year, the Friday before Inauguration Day, which means that many of these projects just have not been able to move forward at this time. And again, under this current regime of the Trump administration, they're proposing and considering eliminating a number of these hydrogen hubs. As you can see, they are located all across the country. In fact, a lot of them are located in red states. The Gulf Coast Hydrogen Hub down in Texas. The Pacific Northwest Hub includes Montana, as well as Washington and Oregon. You have the California Hub. The Heartland Hub is North and South Dakota. The Midwest Hub includes Iowa, Indiana, and some of the surrounding states there. The Appalachia Hub is Ohio, Pennsylvania, and West Virginia. The Mid-Atlantic Hub includes Pennsylvania as well as Delaware and New Jersey. So there's a variety of facilities all over the country, but a lot of them are at risk for getting discontinued moving forward or canceled by the current administration, the Department of Energy. So we are working to try and maintain these hubs. Notably, 6 out of the 7 hubs include heavy-duty transportation solutions as one of their major end-use activities. So they are really meant to start driving some of these large-scale heavy-duty trucking deployments all over the country. And this program was intended to create a national network for hydrogen development, ultimately, including long-haul trucking opportunities across the country. So we really very much need to keep this program in place, and are actively working on that front. So I think that is my last slide if you want to go to the next one. All right, thank you very much. And again, thank you, Rachel, for the opportunity here.
Awesome. Thank you so much, Connor. And I can, if I could have all of our speakers come back, we'll get into some Q&A, and we can go to the next slide. 7, perfect. So we've got a couple of good questions from the audience here. We'll start walking through this. It's a lot of information, which is awesome. And audience, by all means, feel free to send in additional questions as well. So I guess we'll start off one question, and Connor, you may be able to answer this because I saw a couple of them in your membership slide. But which OEMs have H2 ICE and fuel cell vehicle trucks or fuel cell trucks on the road today? And we talked about this a little bit, but the question is hydrogen infrastructure available today? If we could just kind of go back to that part of the conversation here.
Yeah, so Toyota, Honda, Hyundai all have hydrogen trucks on the road today. I know Cummins is also developing hydrogen ICE engines. I think they might have at least some demonstration units out now, but I'm not sure about the commercial status there. But there's a variety of companies, a lot, particularly the existing automakers are very much investing in this space. As far as hydrogen infrastructure and fueling, it's right now there are some bus depots around the country with city, regional transit buses that are operating on hydrogen in a variety of states like Ohio and Delaware and elsewhere. Most of the infrastructure, though, is in California. They have 50 plus public hydrogen fueling stations for their customers and fleets out in California. There's also where the behind the meter facilities are for the initial deployments for hydrogen trucks, which are really around the ports of LA and Long Beach today, is my understanding.
Gotcha. Yeah, and I just to echo that as well. So we have Hyundai is going to be a speaker on our 3rd hydrogen session. Cummins will also be back as well. So folks, for audience members who are interested, make sure that you tune into session 3, which will take place at the beginning of July. So to follow up with on that question about H2 infrastructure, so somebody had put in the chat here. So Rick mentioned that hydrogen is able to be moved through pipelines. Are these specialized pipes for hydrogen, or can it be transported through existing pipelines? And the reason that they ask is because they've heard concern over the years about hydrogen leaking out of existing pipelines because of how small the element is. Is this being improved, or have there been any new developments?
So there's a variety of rules and regulations around pipeline safety. Some of the older pipelines are at risk with hydrogen. Some of the new pipelines are capable of up to 4%. Some have suggested as much as high as 10%. Mixtures of hydrogen with natural gas are possible. The pipelines that are actual hydrogen pipelines are specially designed to move that without causing issues. Uh, Connor, if you want to talk a little bit more about that, if you know.
Yeah, so there's 1,600 miles of dedicated hydrogen pipeline in the United States today, primarily down on the Gulf Coast, but there's some in California and a few elsewhere in the country. Those are specially designed hydrogen pipes, as you said. They follow a variety of codes and standards that are on the table there. There are a number of projects, though, to blend hydrogen into existing natural gas pipelines. So my understanding is you can blend up to something like 20, maybe 25% of hydrogen into your natural gas mixture without any need for retrofits, updating to the existing pipelines or any of the end use appliances as well. There is certainly a lot of projects underway across the country, like SoCal Gas is a big one in particular. My understanding, I think Southern California or Southern Gas is also another one pursuing those projects where they're testing different levels of hydrogen injection into the mixes to seeing how they can accommodate that. Certainly the oxidation issue is one that's well understood and is being actively investigated. There's also opportunities that are being explored to maybe re-sleeve those existing natural gas pipelines with certain technologies or steels that could accommodate that without any oxidation issues.
Gotcha.
Yeah, one other aspect of that is for the trucks. We have Cummins on board here. For the trucks, it's critically important that the hydrogen that gets produced is filtered. It needs to be particularly pure for whether you're burning it in an ICE engine or you're using it in an electrolyzer. So that's something that often gets lost in the discussion. Most of the hydrogen used in the United States does not require really high purity, but for vehicle use, it does.
Mm-hmm. Gotcha. So one question that I actually had, so during the discussion today, we talked about the other industries, the other markets that hydrogen is able to support. Now, when we look at the biofuels industry, there is a concern about the competition between rail and air and marine with trucking specifically because of the limited supply of certain biofuels. Omar, you had mentioned that there are other industries that rely on hydrogen today. Is there any supply or is there any concern about the supply of hydrogen in general competing between trucking and these other industries? Is that I guess, how is that being talked about today?
So, sorry if I understood the question correct. It's between hydrogen and the trucking industry. Can you kind of just repeat the question?
Yeah, sorry. So for the other industries that are relying on hydrogen, so we talk about the fertilizer industry, we talk about air, we talk about marine. Is there concern about these other industries competing with the trucking industry for limited supply, or what does that look like right now?
Yeah, I mean, currently it's a bit of an uphill battle for us to get hydrogen used in these industries, specifically in trucking. So there are, for instance, there's a company out of Canada called H-Tech. They're really looking to get the use of hydrogen trucks mobilized. And in order to do that, they're creating their own fleet to get the ball rolling. Because currently there's just not enough demand from the mobility sector for it to justify these larger projects for hydrogen. So really, from what I see, is there are more spot projects from folks that can actually support it, as opposed to a larger industry push from the mobility sector.
Mm-hmm. I see. Rick and Connor, anything to add to that?
I think when you're talking about hydrogen that's produced from electricity, that's where the demand is probably going to be the issue. We're on a ramp up in creating a more capable grid. So you see these data centers are causing old nuclear power plants to be rejuvenated and new plants being built. So that may be where the capacity issue starts to occur, is on the electricity generation side, to start the process.
Mhm.
Yeah, I'll just add, I think there is, there have been some issues with hydrogen supply for some markets, but that is why we need to get more hydrogen production facilities online. That is why we need things like the tax credit of 45V and these regional clean hydrogen hub programs that are meant to start scaling up this hydrogen production. So there isn't going to be as much competition for limited hydrogen resources or clean hydrogen resources.
I see. Yeah, that makes sense. Actually, we just had a question that I think really builds off of our answers here. So, obviously, and Rick, with your graphic there demonstrating just the sheer number of production methods, we have an audience member who is asking about is whether or not there is a concern for just the number of production mechanisms potentially deterring use in trucking. They're wondering if there is a push toward uniformity, standardizing kind of how hydrogen is produced, and whether or not that uniformity would speed up adoption for trucking.
Yeah, I actually think, like electricity production, there are many ways to make electricity. There are many ways to make hydrogen, and that builds a robustness in it. It builds a market stability by having all those different mechanisms in play. I don't think it's going to be an issue that there is this broad range of methodology to making it, as long as the costs can come down for those different methods. And that's really based on investment and market growth, whether or not those occur.
Mm-hmm. I think that makes sense. And also with Connor, to your point about the all of the above approach as well, it sounds like Rick's answer is very kind of similar to that support of the all of the above production mechanisms.
Yeah, as I said earlier, we have a technology agnostic approach to clean hydrogen. We just need more of it. It doesn't, there's a desire for a variety of carbon intensities in the United States and around the world. There's not really a need to say, hey, you need to have only, 1 kilogram of CO2 to kilogram hydrogen for your production standard. There's a desire for just more clean hydrogen, and different folks will buy at different costs and different ranges. There's not really a need to only have like the cleanest and greenest on the table. We need to have just more general. And on the trucking and vehicle space, our automaker members, at the end of the day, it's going to be the same H2 molecule that goes into the tank, regardless of what the carbon intensity is on the back end. That isn't going to necessarily be an issue. Automakers, customers at the pump, they just want to have hydrogen. They're not going to necessarily care about the exact carbon intensity for each molecule that goes in.
Mm-hmm. Mm-hmm.
Yeah, one other thing, it's a regional solution. So there are a lot of factors involved with where your energy is coming from. So like I said, in the Northwest, it's hydropower. In most of Canada, it's hydropower, but it's also natural gas in Alberta. So, it depends on where you are. There's a lot of other factors involved. And I think, market loves choice. And so there's a lot of choice, and it's going to help develop production capacity.
Mm-hmm. That sounds great. And I think this is a good place for us to wrap up here for today. Thank you, everyone, for joining us today. We will be back here in 2 weeks for our second hydrogen unit session. It is titled Moving Hydrogen from Here to There, the Distribution and Storage of Hydrogen Fuel. Remember to go back to the landing page of this session on runonless.com to take the quiz. It is available now. And be sure to provide your contact information for some messy middle swag. Stefan, if we could go to our last slide here. We have all of our social media profiles listed here, so be sure to connect with us there. We appreciate all the time that you've spent with us today. Very special thank you to our speakers for taking the time to be with us as well. Have a wonderful day, and we will see you here in 2 weeks.